In this video, we're going to do some optimization, which is just a fancy word for finding absolute max and min. So for this first problem, we want to find the number on the interval from 0 to 4. So that's the interval of interest that we're going to use. Those are our endpoints, such that the number minus 3 times its cube is as large as possible and as small as possible. So finding both those things. The hard part about this is we have our interval of interest, but we don't have our objective function. We don't know what we're trying to find critical numbers for. So we have to write that ourselves. So to figure out what that objective function is, what we're trying to maximize and minimize, we can call that number anything we want to. So such that that number, so I'm just going to call it x minus, so I'm going to do subtraction, 3 times that number cubed. So our objective function, what we're trying to absolutely maximize or minimize, I can just call it f of x, is x minus 3x cubed. That number minus 3 times its cube. If it said that number plus 4 times its square root, I would have x plus 4 square root of x. So we just have to read the problem closely and write our own function based on what it's saying. Now we're ready to do our same 2 steps. We want to find the critical numbers and then compare them to our endpoints. So we're going to take the derivative of this. The derivative of 1x is 1. Derivative of negative 3x cubed is going to be negative 9x squared. Or set that equal to 0. So we could factor this because it is the difference of 2 square numbers. It's 1 and 3x getting squared. So we could do 1 plus 3x, 1 minus 3x. Usually that's what we do if we have an x squared. Here I think it might actually be a little bit quicker to use the square root method. Either will work the same way though. So instead of factoring this, I'm just going to add 9x squared to the other side. I'm going to try to get the x on one side by itself. So I'm going to do 1 equals 9x squared. Now I can divide both sides by 9. And I have x squared equals 1/9. And so to get x by itself, I'm going to take the square root. And when you take the square root of a number, you need to do plus or minus. Because, right, the square root of 5, or square root of 25 rather, could be 5 or negative 5. 2 and negative 2 squared to be 4. So we want to include the positive and negative here. And then with the property of the square root, what you do is the square root of the top and the square root of the bottom. So the square root of the top, square root of 1 is 1. And the square root of 9 is 3. So we could have positive 1/3 or negative 1/3. Take the square root of 1 to be 1, square root of 9 is 3. So we have 1 over 3, and it could be plus or minus. So we get 2 x values for our critical numbers. Or the other way, the factoring way, is difference of 2 squares. You would say 1 plus 3x, 1 minus 3x. However you'd prefer to do this, there's just some extra solving involved, but you'll get positive 1/3 and negative 1/3 either way. Whether you want to factor and use difference of 2 squares to solve, or this one, you could actually use the square root method. You'll get the same answer. Our second step, once we find our critical numbers, is to compare them to our endpoints. So I'm going to plug in f of 0, my lower bound, and f of 4, my upper bound. Plugging them into our function that we made. And then we have to test any critical number that's on our interval. So do we have to test both critical numbers? Are both between 0 and 4? No. This one's not on the interval. We don't have to test negative 1/3 because it's not even an option. We're zooming in on this graph that we can't even see, and we're looking what has the highest and lowest y value between 0 and 4. So we can't choose the y value at negative 1/3. It's not on our interval of interest, since our interval is 0 to 4. but we can test 1/3. We're going to be comparing y values, so I'm going to grab my calculator and plug into the original function. So I'm plugging in, I'm going to do 0 minus 3 times 0 cubed, plugging into that original function is just going to give me 0. I'm going to grab 1/3 and plug that in here. 1/3 minus 3 times 1/3 cubed, and I'm getting 2/9. I would do math, enter, enter on a graphing calculator to make it a nice fraction. And I'm also going to approximate it just so I can tell what's bigger or smaller. Sometimes it's hard to tell from a fraction. So that one's 0.2 repeating. And then if I plug in 4 into this function, 4 minus 3 times 4 cubed, that y value is negative 188. So it says to answer two things. It says find the number that gives you the largest answer possible and the smallest answer possible. So the number what do you think? What's the smallest between 0, 0.2, and negative 188? The number 4 gives the absolute min value, negative 188. That's what makes it as small as possible. And then what's the largest it can be? 0 or 0.2? 0.2 would be bigger, so we would conclude the number that makes this as large as possible is 1/3. The absolute max value is 2/9. So the biggest this could ever be is 2/9, and the number that makes that happen is 1/3. The smallest this could ever be is negative 188. The number that makes that happen is 4.